Okay, so um, we need to prove that the tangent here, okay? We have to prove the first question. We need, sorry, I want just to take this off, because this was the question 10. Let me remove this, and I will write here question 1, okay? This will be 1, 1, 2, 1, 1, 1, 1, 1, 2. This will be 1, 2, 1, and this question will be 1, 2, 2. Okay, so our question says that we need to prove that MC is a tangent to a circle at C. So whenever you do Euclidean geometry, make sure that you read the statement, okay? The statement says that A, okay, B, C, D, it's what? A cyclic quadrilateral. So if this is a cyclic quadrilateral, okay, what that means that the opposite angle when you add them of a cyclic quadrilateral will give you 180 degrees, or the exterior angle of a cyclic quadrilateral is equal to interior angle of the opposite angle, meaning that D2 is equal to BX, okay? So we can start by that. So question 1.1.1, so we found already that D2 is equal to B is equal to X. Reason is what? Exterior angle of what? Cyclic quadrilateral. Okay, exterior angle of a cyclic quadrilateral. So we can just do this. This value is what? This angle is equal to X. So now, if this is equal to X, what will be the angle B2, C2, sorry. Remember, D, M, C is a triangle. Can you see? This is a triangle. So if this is 90 degrees, because it's a perpendicular, and this is D2 is equal to X, what will be the angle C2? The angle C2 is equal to what? 90 degrees minus X. Why? Because the sum of an angle in what? Triangle. The sum of an angle in a triangle should give you 180, meaning that M plus C2 plus D2 should give you 180. So if you say 180, it will give you D2 plus M, which is 90 degrees, plus C2. So remember, D2 is what? 1, it's X, okay? We have a plus 90 degrees plus C2. So when you transpose here will be 90. When you transpose this will be X. So C is going to be 90 minus X. So now we have this, okay? We need to prove that this angle is equal to this one, meaning that this angle also should be 90 minus X. Now let's come to this side, okay? Look at the triangle. If we look at the triangle ACB, if this is this angle B is equal to X, what will be A2? According to the sum of an angle in the triangle, this will be 90 minus X, which is the sum of angle in the in a triangle. Okay, so this angle will be 90 degrees minus x. Very important to write any angle that you get. Okay, so now let us look at this again. What will be this angle now? If you look at this chord, you look at this chord, you go there, you go there, you can be able to start from this point A to D, from D to C, from C to A, and the A to D. So because the two angles, they touch each other here to one point, meaning that A1 will be equal to A2, which is 90 degrees minus x. We say angle of what? Same chord. Angle of a same chord. Okay. Now therefore C2 is equal to A2. So it's proven. Okay. So we say that MC is a tangent to the circle so both of them 90 minus x, so same to the circle at C. Alright, so now next question, we need to prove that the angle, the triangle are similar. What normally we do here when they say to prove that the triangle are similar, because this means that we have a similar triangle. Remember, similarity theorem. So you need to prove that triangle ACB should be the same. So we say and. Once we prove, then we put the sign, the three line mean vertical line. That means that they are what the same. So what actually we have to prove here? We have to prove the triangle what? The triangle ACB okay? The triangle ACB is equal to the triangle C, or this is D, or equal to the triangle CMD. So we have to prove that this triangle is equal to this one. Okay, now let's go looking at what we have done already. If you look at the angle C, at the angle A, okay, of a triangle ACB, this is the angle that we are looking for, it's A2, should be equal to the angle C from the triangle what? B, okay, D or C, DM. So we have to prove that these two angles are what? Equal. How we prove it? Can we start by that one? We'll see. Okay. Remember, C2 is what? 90 degrees. Okay? C2 is 90 degrees. So, oh, I'm sorry, here should be A1, It's A2, but what we need to prove was A1. So C2 equal to A1. Now, if you remember the previous question, we found that A2 is equal to C2. Okay? From the both triangle, A of a triangle A CB is A2, okay? And the C of a triangle CDM is which C? C2, okay? So here we say given. This is a given. Alright? Or we can say already proven, okay? Now, the next one we have to prove the angle C the angle C, alright, the angle C is equal to the angle M. But can we jump to the angle B should be equal to angle D? Alright. Now the CM here, you can see this angle is what, 90 degrees, and this also 90 degrees given. Sorry. We have MC here, this angle C. Let's say the angle ACB is equal to the angle M, which is 90 degrees, also given, okay? Now, once you have this, automatically the angle in this triangle, which is B, okay, which is X, will be equal to the angle what? In this triangle, it's an angle D. Can you see that here? D, which is we can call it what? Exterior angle of what? Cyclic quadrilateral. So now we found that all the angles here are the same. The angles are equal. So we come to the conclusion that, let me write it here, our conclusion will be the triangle ACB is similar to the triangle CMB. So similarity, actually, it's to prove it, you have just to prove the angles are equal, the angles are the same. So once you prove it, it's done. You make it. So now here we have a 9, you made it, sorry, 90 minus x, okay? This is also 90 minus x. This is also 90 minus x. So once you have all this angle, 90 minus x, 90 minus x, you are covered, okay? All right. There we go. So now we have to move to this side, to the next question, which is this one. But let me take this off so we can understand the question that I will do now. You know, I'm a soft speaker. I don't, even though I'm also a pastor, I don't preach loud. The same I teach not loud. All right. Now let's look at the question, the next question. But what I like when you're doing the question like this, like this one, you have to separate what the triangle. Let's look at the first triangle, which is this one. Our given triangle. Okay, let me remove this. Let's take the triangle that is given here. This is the first triangle, which is a AMC. And the next triangle is a small one, a similar triangle. We take all the similar triangle, okay? And then we have to put here what? This is a sine of a 90 degrees. We separate the similar triangle. This is also 90 degrees, A. And here, remember, this is A1, this is A2, and this is X. And the X is here, okay? So let's put here dots, let's put here dot, let's put here dot. And I remember it says that this side is equal to this one. So C is equal to B. So we want to prove that, we need to prove now that the CM squared, okay, this is what we have to prove. CM squared over DC squared is equal to M and the AB, okay, over AB. So if we can prove this one, we got 6 marks. Now, how to prove this? We have to start from the similar triangle, okay? Remember here we have a CM. This is CM, okay? Okay? And here we have also CM. Now, if we can start from this small triangle, because we see these two sides are equal, okay? There we go. MC of the smaller triangle, look at this, it's going to be over the similar side. Look at the angle here, okay, and the dot. It's this side, the angle, and the dot, which is AM. There we go. We say over AM. And we move here again. This is X. We move here again. We take MD. Okay? Because here we have MD. Okay, where we go. MD. Do we need MD? Okay, let's try. DC. No. Let's go to MD, okay? What is MD? MD, it's a right angle with X, okay? We say MD or DM, let's call it DM, will be 90 degrees with X is 90 degrees with X, so this will be MC. You got clear? Very good. So we are coming there. Now, if we take this, will be again equal to, if we take this side, the MC. No, we already took MC. Now look at this side, DC. Okay? And with X, with what? X with dots. So what is X with dots here? X with dot will be AC. Alright, so this is what we got so far. Now, we have to look at again this triangle with this one. But if you are clever here, we can cross multiply here. We have MC squared, okay, over AM equal to, we take this one, we say DC, oh sorry, we can take this one dm equal to dm. Okay, let's keep it like that. Now let me use this line. This will help us to separate. Okay. Alright, so now we have to look at this now. We look at the small triangle with this one now. Okay, there we go. We start with MC, which is this triangle, a right angle with dots. Right angle with dots will be over AC. Good. Now we move what? Right angle with X, which is what? CB. We have a right angle with X, which is what? DM. Alright? And then finally, we have okay, right angle with a dot. It's what this side MC. Okay. Oh yes, MC over AC. Okay. Then we have this is not sorry. Okay. Then we have a DC, and then this side we take X with a dot over AB. All right. So this is exactly what we have here. Then we move to the last one, which is DM, which is DM, this side, X with a right angle, this side would be CB. Now, let's now move to what is very important here. If you will look at this part, okay, let's look at this one. Because we already have an MC here, okay? Let's look at here now. We see that our given CB is equal to what here? What is CB? CB is equal to DC, or DC is equal to CB. So what we will do, we keep this one, DC over B, all right? Is equal to DM over DC, because it's given, okay? So the reason what? Given. So if we cross multiply, we'll have what? DC squared over AB is equal to what? DM. All right. Now, if we can use like a simultaneous equation, so this will be like first equation, and this will be second equation. So if you quad these two, okay, can you see? We'll have MC squared over AM equal to DC squared over AB. So now let's cross multiply, okay? Let's just cross multiply these two. Alright, so we'll have a finally this is what we're going to have, okay? we have a MC squared over what? DC squared equal, so they swap, as you say, cross multiply AM over AB. So it's proven. All right, that is your 6 marks. Look at it nicely. So basically here we start from the smaller triangle and we do the similarity theorem with the 2 bigger triangles, and then at the end we will quote them, we'll find the answer. Now let's move to the last question. The last question now. What did the last question say? It's 2 marks, okay? Say we need to prove, once we have this, we can prove this, okay? So when it say AM over AB, which triangle is got AM over AB? All right. Now we cannot look at the AM over AB, but let's look at here. We have a CM squared, okay, and DC squared equal to AM over AB. Now let's look at this side, okay? So if you have a C over C DC squared equal to AM over AB. Good. Okay, so now CM is in this small triangle, okay? So if this is X, okay, CM will represent the opposite side to the angle D. There we go. This is X, this is a right angle, this is D, C, this is what? M, this is a C. So this will be to this angle, this became the opposite side, okay? And this became the hypotenuse side, and this is the adjacent side. So if you want to find the ratio, trigonometric ratio of a sine, it will be sine X will be equal to opposite side, which is CM, over hypotenuse, which is DC. Okay? Now, if you take this one, instead, remember, CM will replace, will have AM over AB equal to, where we'll have CM over DC is equal to sine all squared. So AM over AB is equal to sine squared X. So we end there today. Thank you.